Example 13.7 Part C wants us to divide the statement using synthetic division. Here we have x to the fifth plus x cubed minus 2, all divided by x minus 1. When I see the numerator here, the dividend, I see a degree 5 polynomial, x to the fifth, but this degree 5 polynomial does not have the maximum possible terms that it could. There are some things that are missing, if you will. So I want to rewrite this with placeholders. X to the fifth plus 0x to the 4 plus x cubed plus 0x squared plus 0x minus 2, all divided by x minus 1. Now, we had talked about the idea of placeholders with long division, and it's not 100% necessary to do in long division, but for synthetic division, it is 100% necessary. If you do not put the placeholders in, you will not get the correct answer. Remember, this is a synthetic division. It is a simulation of long division. So if you don't follow the regimen to the T, you will not be able to get this to work correctly. Let's go ahead and draw out our separator. The coefficients will be 1, 0, 1, 0, 0, negative 2. That represents the dividend. My divisor will be represented by positive 1 again. And I'm going to bring down the leading coefficient of 1. And let's start the process. 1 times 1 gives us 1. 0 plus 1 gives us 1. 1 times 1 to get 1 again. Finally something new. 1 plus 1 to get 2. 1 times 2 gives us 2 again. 0 plus 2 is still 2. 1 times 2 is still 2. 0 plus 2 is still 2. 1 times 2 is still 2. And then I add negative 2 plus 2, and I finally get something different. I get 0. Remainder, constant, x coefficient, x squared coefficient, x cubed coefficient, and the x to the 4 coefficient. So the higher the degree your dividend, the larger the degree of your quotient ends up becoming. So let's write out our answer. We took x to the fifth plus x cubed minus 2, and we were dividing that by x minus 1, and the result is x to the 4 plus x cubed plus 2x squared plus 2x plus 2. And since the remainder is 0, we've seen that we don't really have to include that. So the answer to our division problem is just going to be the quotient.